So by y can either change by 1 or say sigma si is equals to x, sigma of si where plus 1 can multiply if y minus x is equal to 1 possible, or or I could have more if 1 so this would reflect in so minus 9 times k and plus 1. It's 9k plus 1. So if the difference is of this form, so if y minus x is equals to minus 9k plus 1, then that means y minus x minus 1 is congruent to 0 mod 9 and y is less than equals to x. Okay, so if y less than x, then y minus x is congruent to 1 mod 9 x minus y. If y greater than x, then x plus 1. Or yeah, x plus 1. and square. Okay. So I move it, so I remove it. So this decrease and increase that by 1, and this remains the same. Number of operations is deterministic. Na minus nb. If it is negative, then no. So na greater to nb. Now if I have to increase it, then I should start matching from the last. Actually, I should start matching from the smallest because I can't change the smallest there. So start matching from smallest. If smallest smaller than that smallest, then increase it to that level and delete both. If so I keep increasing. So now I'm left with, when I have to stop, that means I am greater than everything there. Then what I can do is, but I can only increase it if it's equal. So smallest is smaller than that. I can try moving it there, assuming I have an even number of that. Okay. If num smallest is even, then and doesn't smallest here minus there is even, then divide and move on. If odd, then increase by 1 and continue checking. Actually, I don't divide, I carry it all forward, and yep, carry it all forward. So I do that, carry it all forward, and then check again. So if I do this, oh, B is empty. So okay, so it's B is currently empty. Then I just have to see if I can keep increasing it and until it's even, and then divide. So in mod, so if it, okay, only 1, then no. If greater than equals to 2, if even, divide. If odd, put replacement upwards. not frequency of I continue. If so if I is equal to 1, output no return. And now frequency of I plus 1 plus equal to frequency of I and 1. Now I keep doing this. If frequency of n plus 1 mod 2 is 0. So, or I can just keep pushing 3 upwards and upwards. Okay, if the sum of counts is even, so I waste 2 here. Just 2. I minus 2, I minus 2, I minus 2. So if sum is also not possible, and if frequency is 1 at endpoint is not possible, if frequency of ABC plus 10 power x minus 1 plus 10 power y minus 2, so on. So one thing to note here is axis was 7 times. So when was this 7 times being used? 15. So 17 is not possible. 99. Well, it won't change this number mod 9. This is what? Minus 1 mod 10. Right. This is 99 is minus 9 minus 1 mod 100. Okay. So I can bound this first digit minus 7 plus 10 mod 7. So 5 minus 2, 5 minus 7 is minus 2, minus 2 plus 10 is 7. That's the worst case. N is less than 29. Now 3 is minus 1, 3. 0 minus 7. Mod 100 is also just minus 1. And mod 1000 is also minus 1. So if I do get 7 there, it's just how many minus 1s do I need to do. So how many minus 1s is this? Right. This is just that. Mod 10 power 3 minus 9 is what? 991. And plus 9 is 1000. So this would be what? Adding 1 here, adding 9 here, which is minus 1, minus 1. So it takes at most 7 operations. So 3 takes at most 7 operations. If I try to do this, how many operations will it take? Right. I can just go. Worst case 10 operations. Right? 9 operations. Now the question is, but I add here that also removes one, puts it forward. Removes, but okay, right. So if I want 7 to come here, you have 9 9 9 9 9, or let's say if I put a 9 here, so this puts 1 minus 1 plus here, minus 1 plus here plus here plus here. It just does minus 1 for all these and plus 1 for here. And if I do this, I remove this completely, and this minus 1 goes to, yeah, right. You're just pushing minus 1s. Oh, actually max is 7. Yes. For int I is good. Okay, why? $16. So I turn to 7 option, put here, or I can put what, 1 0 9 8 7 4, or several operations. Okay, I'm missing something. 9 9 9 9. $51. 5 1 7 9. Okay, I should just brute force. Okay, I have two operations. So the points are either this or any of the limits. Okay, I have to just save its I output. So you have these and it's not equal. So you'll never have this, right? 1n, 3n, whatever. And this, okay, you have x1, y1. Let me consider a very small case. So you have x1, y1, you have x2, y2, and you have x3, y3. So in two queries I need to find out. Well, Manhattan distance one property is if there's a path from here to here. Uh, well, and Manhattan distance of this plus this is Manhattan distance of all this. And if it was a graph, you have x1, y1, x2, y2, x3, y3. So depending on if they are the same or not, I would have a graph maybe like also, yeah, something like this. So if I get 0 at any point, I know it's a graph. Assuming xi is not equal to xj. All pairs are distinct. Okay, I can just assume this. So how can I force it to check with 0? Well, I can get x, let's say 1, since it's just two queries, so any 2 will work. So 1 to 2, x1 to, so let's say 1 to 2, the distance. Okay, there are n edges. Can it be bidirectional at any chance? Is there any possibility? Exactly n directed edges. So if I one, two, three, four. So you have 4 vertices, 4 edges. So let maybe the array is what? 1, 2, 3, 4, and that array is 4, 1, 3, 2. So I can't just ask 1 4 and 4 1 because it's possible that both might have an answer. If both have an answer, uh, so what of the parity? That just depends on x minus 1 and 1. If there exist duplicates, xi's, then ask for both. So you have two outgoing edges, y j, then uh, yj, and right, some of them won't appear here. So if I have y and j, basically my idea is if I have a node which has multiple, so I do something this. So, but that's way too many vertices. I don't think this is possible. So if I have a directed graph of n vertices, I can, this will be a functional graph, right? And since it's directed, either you have this cycle if I do 4 and 5. So let's say have 1, 2, so if all distinct, what happens if all distinct? If all x are distinct, all have exactly one outgoing edge. Just multiple cycles. It's just going to be multiple cycles. But if they are, can I deduce something about that? When will distance be same? Will distance same if there are a cycle? I mean, I can have this. It's a permutation cycle, right? What's the smallest n? 3. So consider this case and one here, one here, and one here. So this is 2, this is 2, and this is 3. Transposition would work anyway. AB, but it would be unequal. It will only be equal. Okay. If dij equals dji and okay, well, you could have this. 1 2 3 4. So if I ask 1 2, so if I ask this I get 2. That's fine. How do I distinguish between this and this? 1 2 3. Let's say this. I can have distances of 1 2. I mean, if something is same, then yes. Oh, if it's 1 and n, I have a distance is greater than equal to n. But max distance is here. Oh, so I ask 1 and n if distance is greater than equal to n, then coordinate greater than n, then coordinate. If distance is equal to n, ask n to 1. If 0, then graph, else coordinate. If not equal, that won't work. If 1 comma n in the, so small and max, if small and max is equals to n minus 1, then I could So say I have this. Say I don't give you max. I give you all 2s. So 2, 2, 2. Then easy. Also the directional edges come from me, right? Oh, okay, 1, 1, 1, 2, 3, 4. So you have 5, 6, 7. Oh, I don't will should not have. Okay, if something's not there, it doesn't have any outgoing edge. It has only incoming edge. So I ask 5 comma 1 if greater than 0, then coordinate. So has to be distinct. Distinct. Perfect. If perm else int not. Run map int comma int frick or auto xi x if so frick xi plus plus or int I is equal to 1 I less than n I plus plus if not frick of I yes be return. So if it's a permutation, first let's assume that it is So the equal or greater. Is greater than n minus 1. Yes, b return. Now we know rest is equal to n minus 1. So int rest2 is equals to ask pos n, pos 1. If rest2 is equal to 0, guess a return, guess b return. 3 1 2 3. One three. That doesn't print 1 3. So 1 2 3 2 0. Missing some case. अरे शुद्ध है. Subsequence. So I have to maximize the length. What's the nature of such a sequence? Min is greater than or equal to max. So C is solvable. Okay, let's look at their examples. Why do I have to break my head? First calculus 43210 is magical since min of 43210. Okay, right. Descending order is always descending order is always magical order permutation. Okay, now get some idea. So let's minimum length. So one, what's a two? On length 2 you have a1 a2, so a1 should be getting equal to max of a2, so you can have a1 comma 0 where a1 is getting equal to 1, a1 comma x where x getting equal to 1 and a1 anything. So now of 3 would be okay. So since if there's a 0 here, so if 0 next, okay, if you have a 0 then to its left will always be a non-negative number, positive number. So any random term any sequence of positive integers is always magical since max is what, 0 and min would be greater than 0 always. Also any sequence of positive integers where 0 is in the beginning and after it is all positive integers is also always good. Now say this is good with max m, so this should be equal to m for all this. So if right, so only shit matters if I hit m plus 1, then I would need everything else to be greater than equal to m plus 1, m plus 2, right? So say I have a subsequence of max m and this is good, then I can have anything here which is anything greater than m max, then you have m, then this is the new max m dash, then you have anything greater than equal to m, anything greater than m dash, and you can have m dash and so on. Okay, so this is the construction. So you have nos max, nos can equal to max 2, nos can equal to max 3. Perfect. So if I want to maximize it, I can. Interesting. What would maximize this? So this puts a constraint on whatever comes to its left. So if I remove that constraint altogether, then anything greater would apply, right? I want to make sure the mix is as small as possible so I can have more numbers that are that I can take within me. So okay, so let's take a sample test case and analyze. So 4, 3, 2, 1, 0, all these are bad. Let's check the second one. So say I start from here. Oh, what are some other constraints? I can just make sure everything's good in +1. That's not a problem. So I have 0 and current max is 1. So if I check what I can take max, I can take with never taking 1 is this frequency minus num max. Then I say I take max. So take it, it's better take whatever comes first. So 1 and then I check 2 so dpfi if I take it. Okay, I should dp of I is max subsequence length assuming max till knows I. Right. It is beneficial to take the max if only there is exactly one max and okay, if I don't take the max, I get rest minus count of max. If I take the max, then I can't take any other max, so I can take at most rest minus count of max +1. So I have to check if this is possible, which is a big claim. For this it should be either new max shouldn't exist, either all no's. So if I take 0, say last, then I can take all greater than 1, or take 1 and take all greater than equal to okay, I can actually store, since the lengths are non-intersecting, I can store dp of I is equals to max subsequence prefix assuming max uh, max is I. I plus 1. Basically, I can't take let me just look at these cases. So in this case I take 0, then I don't take 1, so 2, 3, 3, 4, so that's 5. So I take 2, I don't take 0, 2, 1, 2, that's 3, 3, 4, 5, 5, 3, 3. No, 2, 0, 1. So if I take this, then max is 0, I can't take this 1. Or if I take that, I can get it. Is it ever harmful to take it? It's only harmful if that's a 0. If last is 0, check by counting non-zero, and then check by taking last. So I take M, plus 1, dp of I is max subsequence prefix with max up to now is v of I, so new is v of I plus 1. So what I can do is I can check this dp of I, or so get the nearest m and dp of I plus 1 or dp of here. I can just cover it deterministically. Perfect. Okay, how do you initialize? dp of dp of 0 is 1, dp of 1 is quite easy. So maintain a set tree to calculate num greater than equal to, and actually num greater than true minus num me, then check for the next max m plus 1. If I found it, then I go there and then check that. Meanwhile, keep sitting here, and if and keep updating. M1, M2. How much time do I have? 40 minutes. Let me just quickly formalize it properly. So dp of 0 is 0, dp of I is equals to num in prefix greater than v of I so max plus 1, or so initialize it with this, then check for v of I plus 1 such that j is less than I. Go do dp of I is equals to max dp of I comma dp of j plus 1 and so then you so you'll say you have I, j, k, l. Now say this is vi, this is vi plus 1, vi plus 2, vi plus 3. Now I can only take this if I have taken this already. So vi is either I take this and then this, or would this really, if I vi plus 2, vi plus 3, it could really, right? Actually, they are not non-intersecting technically. I just have to check if it's reachable. So for each number, I have to check what's the max reachability. That is, if I start from vi plus 1, can I go here? But that would mean ignoring everything here. Is it ever better? I mean, if I take this, I am also taking all of this. So that might overcount. Maybe suffix is a better idea. So let's say you have x and you have some lens. Right. So if I go from right to left, I can add its count to everyone who has a max less than me, and for the ones who have max equal to me, I can say that's the new DP of 5 plus 2. Right. So DP is from maxes to largest count. Now I have to maintain the new mix. Is it anyway obviously better to go somewhere else? So I can't take I minus 1 anyway. Right. So if I have Vi with max M and you have Vi, we have M here. If they are adjacent, always take. Only better taking if Is this always also better? No, never better. So say you have vi plus 1 here, right? So say if I have a vi plus 1 here, if I just didn't take this, I would have both, right? But if I take this and I take this, then I risk not taking this. So this same, but now I risk not taking vi plus 2. Wow. So if we have vi, if I have vi and I have vi plus 1, so if I have vi and you have vi plus 1, so this is the max. So if I case 1 take, say I take this, then in that case you have max m, max vi plus 2, can't take, so you take 1 less plus 1, but now can only take utmost 1 vi plus 2. Don't take all vi plus 2 and no more, just no vi plus 1. Only take if adjacent. So now if I start from 1, so if I take this, I have a deterministic algorithm. So if so I take this, if this is greater I take that. So 1 is if nothing greater, then I take that. If not, so if I take the last and next is not max, I take everything else other than that, and that's my answer. If not, I take this and encrypt and mix and check. Alright. Okay, then equal greater than curve and super is equal to y. So this is wrong and this is wrong. How do I stress test? Fuck. All non-zeros will work, and whatever the max is there is fine. And currently the answer is cur. Uh, uh, so max amount I have taken, and secondly, for each value, if it's greater, then I can always take it. Oh, it's also okay if m plus 1 m plus 2, assuming all bs. So 0 1. So 5. So I have 0 1, then 0 2 3. So this should be 1 2 3 4. That's only optimal if current is max. That's always optimal. Is it always optimal to take if so x plus 1? So if I take this, I can't take any more x plus 1s. That's okay. Plus 2. So you have x plus 1, x plus 3. It's never optimal to take if it's farther. It has some useful here. It's never. Oh, I can do that. All greater. Frick of x star domain x command plus 4 plus plus. For int I equals to n plus 3 and getting 0 I plus plus frick of I plus equal to frick of I plus 1. Frequency of curve. Curve plus frequency of curve plus 1 plus v of 0 is equals to curve. So whatever is greater plus if that's 0 or not, I just do it, and perfect. Say if I take this, it's that, and if I whatever's the max now, that what is greater than equal to that plus that many numbers. But starting should be if that's that, then okay. But it's also, thing is, you can have m plus 1, m plus 2, m plus 3 also. Point is, but I won't be taking this because that's the issue. But right, so it might be optimal to take something from the starting, it might be optimal to take something from the end. Let's take something from the starting, either take something from the end, skip all lesser. I understand that I'm not considering the case where so the exact case I'm not considering is, so you have 0, 1, and then that's a big number, 0, 1, and then 2, 3, and let's say the number here is 5. Now, because stop here, I take this and don't us. How do I solve this? When is it okay to take? Just take and be okay with it. So I know if I don't take what's answer, will skipping ever be better? So my question is, if I have 0, 1, and you have a 2 and a 3, and this is a 4. So if I just skipped and take all 4s, so let's just 4, 4, 4, 4. In this case, what should I have done? If I take 0, 1 and then 3, 4, 4, 4, versus I would have taken 0, 1, 4, 2, 3, and I won't take any 4s. So it's not always easy to say that. Find the max mix. So this is the max mix. All no's here are greater than equal to max mix. So 2, 3, 4, 0, 1 would be feasible, but I only have 2 minutes. What's my standing? Okay, I'm missing something, but it's not apparent how to solve it, and definitely won't be able to figure out in 2 minutes. But basically, let's see. Uh, 237. I think it's fine. Let's see. But basically, what the logic for D was. So there are 2 cases. Let me explain it to code. So if all numbers between 1 to n appear exactly once, so it's a permutation, then I test whether so I find the indices where there's 1 and n, and then I ask what's the result for these positions. And so my test is basically, if it's a coordinate system, then the difference between x's would at least contribute n minus 1, so the total Manhattan distance would be at least x minus 1. So basically what I'm saying is, so if you have 1 and then you have n, and so this is y1 or y2, so Manhattan distance would be this, let me show more, plus this. So the distance should be at least n minus 1. So if the distance that I get is less than n minus 1, then I know it's a graph. If it's greater, then I know it's a grid, because a graph can't have a distance greater than n minus 1. and so if it's equal to n minus 1, then all the edges were used to construct this path, and so all the edges were used to construct this path, and there might be a special edge here. So what do I check? Oh shit, uh, if s2 is equals to so greater than equals to n minus 1, guess B, guess A. Oh shit, I'm gonna FST. So the reason I think I'm going to fail system test is right. So yeah, I'm going to fail system test. So the reason I'm failing is, consider this graph. So 1, 2, 3, 4. So here, so 1 to 4, there is a path of length n minus 1, but 4 to 1 there is a length of path 1, and yeah, but mine would return that this is a coordinate system, so I should have just done that. Shit. Anyway, then what was B? So B was, I'm trying to make the smallest numbers equal first. So I if let me show you the code. Uh, so let me just see first. So see, I just guessed that maybe adding only one type of nines would work. So 9 nines or 8 nines or nines. So just tested with each possible option and then I return the answer. And for B, I had two options. So if there's odd number of numbers, then it's not possible. So if there's no number, I just continue, and if there's just one, then I can't split it, nor can I increase it. And if not, I just leave two behind. So one would go to A array, one would go to B array, and then the rest would move forward. And VMA is check if y minus x is 1. If that's 1, then it's always possible because you can have a series of ones and then plus 1. And otherwise, what would happen is you would have a series of 9, so you would be removing some 9s from the answer and then adding 1. So that reduces to the subtraction being modulo 8. So yeah, I think it's a pretty bad round since I'm going to FST, but yeah, it was pretty fun.